In this demo, we show how discovery and MCP-based execution are combined within the MEF-DEV agent fabric, fully aligned with the TMF-939 Agent Management API. We start with a simple MCP invocation from a chat environment, and then demonstrate how the very same request is processed inside the multi-agent platform, from agent discovery through coordination to task execution. To demonstrate this flow, we begin with a few preparatory steps. First, we register an MCP connector in a chat environment. For this purpose, we use LLM Studio, which is functionally similar to ChatGPT or Claude. Authentication is performed using an API key, although the platform also supports OAuth 2.0. Our MCP connector exposes two tools: Test and Offering AI Estimate Conversation. For this demo, we use the Offering AI Estimate Conversation tool. In the chat, which is connected to the OpenAI GPT-OSS 20B foundation model, we formulate a request and explicitly instruct the model, via the prompt, to invoke and use the Offering AI Estimate Conversation tool to generate the response. As a result, we receive a successful, human-readable response from the MCP tool, fully aligned with our request. Now we demonstrate how the same process is implemented on the MEF-DEV multi-agent platform, and we introduce the ecosystem of registered agents. Discovery is not just about finding agents. It is about preparing for execution. In complex cases, the platform switches to agent-to-agent discovery, where agents interact with each other, extending simple lookup into execution-assisted discovery. If the initiator does not implement its own discovery logic, the platform identifies a meta-agent orchestrator. The orchestrator analyzes the request, selects candidate agents, coordinates their interaction, and produces the final outcome. From the initiator's perspective, the interaction is simple. It receives a single agent ID and communicates only with the orchestrator via the standard post-chat method. All multi-agent complexity remains encapsulated within the agent fabric. In this strategy, the initiator is a TMF native agent with its own discovery capabilities. The initiator independently performs agent lookup using the local agent registry. It then directly interacts with candidate agents, discussing options, refining solutions, or delegating execution. The platform provides the registry, policies, and standardized communication interfaces. The executor-first approach is used when the agent is sufficiently autonomous, in other words, TMF native, and can manage discovery and coordination itself, using the agent fabric as shared infrastructure. Discovery always starts with the local agent registry. Different lookup modes are supported, including strict filtering and semantic search. The outcome of this phase is a list of agent ID values for subsequent interaction. If needed, the platform can transparently enrich results using external agent catalogs. Regardless of the selected strategy, the initiator always works with a single discovery interface, while all lookup and reconciliation logic remains under platform control. On the screen, you can see the Agent Management Control panel, the interface used to configure, manage, and operate the TMF-939 Agent Management API. For this demo, we pre-registered 3 agents. Offering AI Orchestrator, the main meta agent responsible for coordination. Function Discovery Agent, a goal-based agent that determines required functionality. And Execution Agent, a utility-based agent that performs the task triggered by the MCP tool. At this point, the video shows agent registration and the input-output of one agent in the AI agent playground. For the demo, we used internal agents built with BPMN low-code and deployed within the MEF-DEV agent fabric. External agents implemented in other programming languages can be connected in the same way. The fabric simply invokes them via standardized interfaces. On the screen, we now see the meta agent executing a sequence of actions to coordinate the other 2 agents. Next, we switch to the Agent Composition Pipeline interface, where we show the execution history as completed pipelines. Here, we can see that Offering AI Estimate Conversation was executed successfully, and on the right side, we see exactly which agents participated in this pipeline. This tool is particularly useful for debugging, analysis, and monitoring multi-agent interactions. From a technical perspective, All interactions are implemented using the standard MCP protocol. We now demonstrate that executing the same scenario via Postman yields an identical result. The next method demonstrates the discovery phase of interaction with the agent fabric, specifically searching for agents capable of performing the required task. In this example, we run a simple lookup based on exact capability matching, but the platform supports multiple discovery modes, including semantic search and skill taxonomies compatible with the agency agent framework. The final method shown in Postman is inter-agent communication via the chat method, which is the core interaction mechanism of MEF-939. It requires agent identification and a standardized OpenAI-style message format, which can be applied uniformly to any agent in the system. Thank you for your attention.